Welcome back to a lecture series on digital image processing. In this practical, it's a hands-on training practical. So in this practical, what we are now going to discuss about the NDVI, Normalized Density Vegetation Index. And now we'll start the exercise on NDVI. So I'll just give the brief introduction about this. As you know, NDVI is the expansion. So I'll take a minute to explain about this. Normalized differential vegetation index, NDVI. So this is abbreviation of normalized density vegetation index. Okay, now it's very clear. So the NDVI formula for the NDVI for calculating this, it is near infrared minus red band information over near infrared plus red information. So this is NIR minus red divided by NIR plus red. So now I open the Ndvi window. So I am just taking the data. Now opening the data. So I am taking the Sundarban multi-spectral image, and you have 3 bands information. Sorry, 4 band. The present one is a 3 band. There are 4 band normally it carries: green, red, near infrared, and short wave infrared. So this is from data manager, you will be able to understand. So this information, you see there are 3 band: NIR minus red, NIR plus red. Normally how we will take this information in encoding in digital image processing software. So we have to type this, no, otherwise you have to understand first what is the band it is. So band 3 minus band 2 divided by band 3 plus band 2. So 3, you see 3 NIR is 0.8150 at here. The red portions it is 0.650. So that's why I am just putting, typing here B3. Simply if you want to express B3 minus B2 over B3 plus B2, band 3 plus band 2. So this is how we normally express. What is B1, B3, B2 we know. But actually how we will type this in the digital image processing, in the unit, you will have to, you cannot simply straight away to type this. So you have to write a simple algorithm for this, to keep in the Ndvi platform. So that I will type here, so that we will be able to copy it from here. Float within bracket start, float within bracket B3 within bracket close, and the minus B2, it means you are taking the information, float. So this is the sign symbol of digital image processing. You have to type like this: float B3 within bracket. So there are 2 bracket, you see, 1 bracket starts and 1 bracket at the end, and in between you put your B3. So this is the formula we use for band ratioing. So you will be taking this for assessing normalized differential vegetation index. It is not density, it is differential vegetation index. And this once if you know this is how we will have to do it. We can go straight away in the digital image processing area. You copy here, minimize this, and close the data manager window. Band ratio, band math. So this is how the formula is typing here, the math formula. Right click and then paste it. Once if you paste, add to list, if you give, automatically on the top this will come, float b3 minus b2, and that will come, and give OK. And here now we have to assign the band, and band 3 and band 2, as we know what is band 3 and band 2. Otherwise you can also refer, because it is undefined. You look at the top, it is undefined. Now look at here, NIR minus R. So what is band NIR? This is R, this is band 3 minus, so band 3 we have to refer NIR. This is very clear, right? You have to define undefined, now you have defined, and you will have to give the output file name as ndvi dot dat. So you have assigned your output feature file, then give OK. So it takes only less than a few seconds to finish this, and it is displayed here, ndvi.dat, band math of the applications what you did. So what now, you take the cursor, cursor value. So there is a few error is coming. As cursor value you take, once this will come. Now look at wherever you move the data, you just see the data is changing. Now 0.42, and then you just move on over water body, over thick vegetation, over light vegetation, and all. It is very interesting. You can take even the FCC at the back end and then swipe the data and do it. Otherwise you simply run through, and even you see the darker patches, what is the value data. You look at the data, and you will get an idea that NDVI, there is so much of work which you can refer from the already existing literature. We can do a very good interesting information extracted from the vegetation, normalized differential vegetation index, right? So after understanding this, the cursor movement and its value assessment, we'll go to remove the cursor. So this is the button we have taken. Now we are removing it by showing the arrow. And once if this is done, now we can reclassify this. It means you can, now it is black and white format. So only it is with gray color it is represented. We can go with a number of colors to define even the vegetation, light vegetation, thick vegetation, and so on. So take right click and raster file selection, and you see you remove all the classes which is already set by the default system operations. Now try to give with only 4 and then see what is the difference it looks. The data minimum is 0.58, the data maximum is this is minus 0.58 to maximum 0.5. So this is the data difference. Look at the data difference, minimum maximum, and now you see it is equally classified. Once if you apply, it will come the equal classification. Suppose if we know by operating this NDVI over the period of 10 decades, we knows that grass will have this much of reflection, thick vegetation will have, forest will have. Maybe simply you put minus 0.5 to 0 one class, and 0.001 to so I am now redefining the classes, the negative value as one class, and then the positive value you can define. Now it is 0.0001 to 1. This you can simply type to look at your data. Sorry, 0.2 and 0.2 to 0.3, 0.2 to 0.3, and 0.35 to the maximum, that is 5.5. That you don't need to define because it is automatic. Now you simply give OK and see the result of it. Yes, now you can also edit the color according to your interest. That the low is make it gray in color, because there you won't get much vegetation. The higher reflectance will be of green in color. Like that you can change according to the better way of display. So because graphical interpretation is one, everyone will understand that how it gives more enormous informations. So I am now changing the density of green to show that where the density is more with respect to vegetation is concerned, and give OK, and then the final one which is more vegetation, so it's thicker green. So this is how I did, and then we can apply and then check. Give OK. Now look at the water body is black in color, and vegetation thickness, if density, lower vegetation, medium vegetation, higher vegetation. There are three classes. Among you see the dark green color represent the thickest vegetation. So it is like this we can do wonder by applying this. We can interpret enormous information with respect to vegetation. It is direct indicators for many studies. It is indirect indicators for many applications like water, the direct indicators even for many applications, and indirect even for mineral exploration. This type of geobotanical indicator is being used. So you can see, you can check in, check off the you see the thickness of vegetation. Thickness of vegetation is very well demarcated in no time. It takes only less than few seconds to do all these operations. That is the beauty of Ndvi band math. Like this, if we do, we can interpret very well, uh, and a good amount of information we can extract by using this type of applications. Like so with this the application of Ndvi is come to an end. So thank you very much.